right, last video left off on example 9. We had started it, but we ran out of time. And we were solving rational equations. So the first thing we did, we factored each denominator using t-chart and divide and slide, and we actually did have to divide and slide on that one. And then we rewrote each problem with the denominators factored, right? And then we determined that our least common denominator was x plus 2 and 3x minus 2. So we're at the point where we need to multiply every term by the least common denominator. And since I don't have a whole lot of room, I'm going to kind of jumble it all in there, okay? So you know what you're supposed to be doing. So I'm going to multiply every term by x plus 2 and 3x minus 2. You don't? Okay, on my desk on the corner, there's 2 separate stacks. So just get whichever one you need. And so then once I do that, then I'm going to go through and I'm going to cancel out any factors that I can. So in the first term, the x plus 2's cancel and the 3x minus 2's cancel. And then I've got equals. On the right side, 3x minus 2 and 3x minus 2 cancel. And then I have minus. In the last term, x plus 2 and x plus 2 cancels. And 3x minus 2 and 3x minus 2 cancels. So then we're just going to go see what's left. So in the first term, everything canceled except for the 2. So 2 equals. The next term, I have x plus 2 and a 5. I'll put the monomial first, and I'll have to distribute it to the x plus 2, which I'll do on my next step. And then minus, the only thing I have left is a 1. You have to put that 1. When you subtract the 1, it changes the value, right? When you multiply by a 1, it doesn't, but subtracting a 1, it does. So this one's going to be pretty easy. We're not going to have to factor to solve or quadratic formula or complete the square or anything like that. We can just solve for x. So the first thing I'm going to do is distribute. So 5 times x is 5x. 5 times positive 2 is positive 10. Bring down the minus 1. I've got like terms on the right side. So 2 equals 5x plus 9. Then I can just easily solve for x by isolating it. So I'll subtract 9 from both sides. 2 minus 9 is negative 7 equals 5x. Divide by 5, and x equals negative 7/5. Or in decimal form, negative 7 divided by 5 would be negative 1.4. Remember I told you on your test it's going to be some multiple choice and then some not multiple choice. So on the multiple choice ones, if it's in decimal form or fraction form, you need to know how to convert to both, right? Now you need to make sure that your answer is not going to give you any zeros in the denominator. So I would look at the factored part. If x was a negative 2, that would give me a 0 in this factor. It's not, so I'm okay there. On this one, think about if I set it equal to 0 and solve for x, I would add 2 and divide by 3. So if x was positive 2/3, I would get a 0 in this factor, and this factor, and it's not, so I'm okay. It's not extraneous. As long as I did my math right, I'm okay. Cool beans? Now, if you weren't here last class, once I finish, you can borrow my paper, or I posted the video on Edmodo. You can go back and catch up on the part you didn't get. So on this one, I had trinomials, binomials, trinomials. But look at number 12. Those are just monomials, right? So when you find the LCD, it's a little bit different, because if everything's just a monomial, you don't factor them out. What's the least common denominator going to be on number 12? 6a. Because think about it, if it was 2a, if I multiplied this first term by 2a, would my denominator cancel out? No, when I reduce it, I'd still have a 3 down there, right? So, it's still 6. Still 6. So I'm going to multiply every term by 6a. And then I'm going to cancel where I can, reduce where I can. So in my first term, 6a divided by 6a is 1, so we just say that cancels. 6a divided by 2a, is that 1? No, well, it's just, what's 6a divided by 2a? 3a? Isn't a divided by a 1? So it's just 3. Over here, 6a divided by 2a is 3. So my denominator canceled. I have a 3 in the numerator on both of those. Right? It doesn't make sense? That 6a divided by 2a is 3? Well, a divided by a is 1. Anything divided by itself is 1, right? So if I just had a divided by a, wouldn't you say, if I have 2x divided by 2, don't you tell me that's just x? Right? So if I had 6a divided by 3a, well, 6 divided by 3 is 2. A divided by a is 1. So basically, 3a divided by 6a is just 2. Okay? Oh man. So now I'm just going to go write whatever I have left. So in my first term I have a plus 4. There's nothing to multiply it by, so just a plus 4. Then it says to add. In my second term I have 3 times a plus 5. And then I have an equal sign. And then in my last term I have a 3 times a plus 4. So let me distribute to get rid of my parentheses and see what we have left. We have a plus 4 plus 3 times a is 3a. 3 times positive 5 is positive 15 equals 3 times a is 3a. 3 times positive 4 is positive 12. I don't have any quadratic terms. I just have linear and constants, right? So I know I can just isolate the a. On all of these, I believe I've checked when I made the review, I made it so that you shouldn't have anything that you have to do factoring quadratic formula or divide and slide. I mean, factoring quadratic formula or completing the square on the rational equations, okay? I made it so you'll just be able to solve for a on the rational equations. Okay, on the left side, let me combine like terms before I start moving stuff around. What is positive 3a and positive a? 4a. And positive 4 and positive 15 is positive 19 equals 3a plus 12. Now what should we do? Yeah, is that the only thing we could do? No, there's like 4 things we could do, but that's what I would do. I like to get my a's together first. 4a minus 3a is a plus 19 equals 3a minus 3a is 0 equals 12. Subtract 19 from both sides and a equals negative 7. If I substitute negative 7 into any of my denominators, will that give me a 0 in the denominator? No. And it's okay if I have a 0 in the numerator. Not that I would get one, but you can have 0 in the numerator. You can't have 0 in the denominator. Right on? Crouton. Coolio? So all of the other two, actually 4, 1, 2, 3, 4, solving rational equations. And I want y'all to do those on your own because those are the ones you struggle with. They shouldn't be too hard. I didn't give you hard ones. Let's look at 10 real quick. Can you factor 2x plus 2? It's linear, but is there a GCF? Yeah. So you can factor that out, okay? 2x squared plus 14x plus 12. That's a quadratic and it's got a GCF. It's the same as this one, right? So you need to take out the GCF and you can probably factor it further and then figure out your LCD, multiply everything by the LCD. On 11, can I factor x minus 4? No. But this quadratic, I can probably factor that. So I need to before I determine the LCD. On the back side, can I factor 2k squared plus 2k? Yeah, what's the LCD? 2k. 2k. I mean, I didn't mean what's LCD. I meant what's the greatest common factor? 2k. So factor it out, see what's left. Can I factor n squared minus 6n? So there's a GCF, right? And once you factor it out, what's left won't be factorable. And these two are the same. Can I factor n minus 6? It's linear. The only way to factor a linear is if there's a greatest common factor. Is there one? No. Okay. 15 through 18, those are radical equations. So let's do 15 together. Remember, the first thing you have to do is isolate the radical if it's not already. Yeah. I'll let you see it when I'm finished with this one. You can have my paper.
I need to see it too.
Okay. Let's do 15. When you're doing radical equations, the first thing you want to do is isolate the radical. If you have radicals on both sides, you can't really isolate it. But if you don't, then isolate the radical. On 15, do I need to isolate the radical or is it already? It's already isolated. So what do we do?
Square it.
Square both sides. So x raised to the second power is just x squared equals, what's the square root of negative 36 plus 13x quantity squared? You know it. Okay, I have quadratic terms and linear terms. So can I just isolate the x? No. I'm going to have to either set it equal to 0 and try to factor a quadratic formula, completing the square, whatevs. So x squared, that's going to be my highest degree, and it's already positive, and I want to keep it positive, so I'm going to have to bring everything over to the left. So I'll add 36 to the left. I'll subtract 13x from the left. So I have a 0 on the right. On the left, none of those are like terms. Make sure you put it in standard form. So that's x squared minus 13x plus 36. Quadratic trinomial. I'm going to try to factor it. If you want to go straight to the quadratic formula or completing the square, go for it. But I like to factor if I can. Is there a GCF? Nope. So define A, B, and C. What is A? 1. What is B? B, negative 13. C, positive 36. I need two numbers that multiply together to give me A times C, which A times C is positive 36, and then add to get B, which is negative 13. Negative 9 times negative 4 is positive 36. Negative 9 plus negative 4 is negative 13. Sweet. So my factors are x minus 9 and x minus 4. Do I need to divide and slide? No, because A is 1. If A is anything other than 1, then we do. So, have I solved? I got to set each factor equal to 0. So, x minus 9 equals 0. That means x equals positive 9. X minus 4 equals 0. That means x equals positive 4. Now, remember, on these radical equations, we get extraneous solutions a lot. And if you give me one of these answers and it's extraneous, that's wrong. So, it's imperative. What does imperative mean? Really important, that you check your work, that you check yourself before you wreck yourself. Okay, so let me see if I can squeeze that in. I'm going to check x equals 9 first. So that would be 9 equals the square root of negative 36 plus 13 times 9. 13 times 9 is 117. So negative 36 plus 117 is 81. And what's the square root of 81? 9 equals 9. So we know 9 is a solution. Does that automatically mean that 4 is not?
4 is the solution.
Is it both? Can we have 2?
Yeah.
Yeah. I'm going to check it anyway. So I have 4 equals the square root of negative 36 plus 13 times 4. So it's 4 equals the square root of negative 36. 13 times 4 is 52. And negative 36 plus 52 is 16. What's the square root of 16?
4.
So that 4 is also a solution.
I have a question, Shirley.
Yes.
So you know how we
Bless you.
changed it into that standard form?
Yeah.
Can we just plug in the numbers for that instead of doing the square root stuff? That's what I kind of did.
No, because that square root is what's going to make the difference.
So I got lucky this time.
Yeah, because they both were solutions. But because they say you got a negative under the square root, and that would give you a imaginary solution. So you want to do it under the radical. Okay. Okay. So guys, let's say on 18, I have a radical on each side. What am I going to do? Square both sides. So what's the square root of 1 minus 6m quantity squared? Equals, what's the square root of m plus 8 quantity squared? Well, it's going to be easy. What should I do? Add 6m. So that's 1 equals, what's m plus 6m? Nice. Then what? Subtract 8. 1 minus 8 is negative 7 equals 7m. Divide by 7, and m equals negative 1. So they say, we're going to check our work. So we have 1 minus 6 times negative 1 equals the square root of negative 1 plus 8. So that's 1. What's negative, bless you, what's negative 6 times negative 1? What? Positive 6. And negative 1 plus 8 is 7. So does the square root of 7 equal the square root of 7?
Yeah.
Do I even need to turn it into a decimal? No, I'm going to get the same thing, right? So negative 1 is a solution. Yay. There you go. So I want y'all to work on this. I'm going to go ahead and pass back these completing the square notes. I know we did this example, but I'm going to go ahead and give you those notes back so you have that to look at. And your rational equations notes. And I don't have the radicals recorded yet, but I think y'all are okay on that. Okay? And next class I can give those to you and when everybody else comes back. So we'll continue working on this today and next class. Alright, so our test won't be until after that. So let's just work on this now. Don't worry about doing it for homework, but for class right now, I want you working on it. I'm only talking to 5th period. None of my other classes. This is just 5th period. My other classes will listen for further instruction. Okay, I could have just stopped the video before, but